Hello everyone. In this video, we are going to go over a problem that actually showed up in a previous exam um, in order to see more examples of how to do our confidence interval problems. So the other thing that I'm going to be using is I'm going to be using this kind of flow chart that we've been using in our other problems. You can download this from the class website. I'm going to go to our page 3 real quick. And this is going to help us figure out exactly where we are and what problem that we should do. And then we're going to use Excel to actually do our calculations. So here we go. So it says you are working as an intern for a marketing firm and have been asked to sample college students about their preference for daily autumn apparel given their choices: flannel, shirt, hoodie, sweater, other. Out of the 76 students, 29 selected hoodie. Okay, let's see kind of like what is our data type and what's going on before we even take a look at our problem. So the first thing that I want to put up is like, what is our question? And let's zoom in just a little bit. Oops, sorry, wrong way. There we go. What is our question? And then we can say, what is this like? Daily autumn apparel preference. And we're going to basically, we have a whole bunch of choices. We've got flannel, shirt. Oh, sorry, that's one idea. Flannel shirt, hoodie, sweater. Oopsies. And other. Okay, so those are what's happening. So our variable is going to be, we'll call this just like clothing preference. And the data type, just getting set up here, just identifying what's going on, we have a piece of categorical data. Now, when we are dealing with categorical data in this class, we are going to be, so far, doing what's called dichotomization, and we have to take the data and make it one of two options, basically a yes, a no, a success, or failure. And right now, it looks like that what we are interested in is hoodie, oopsies, hoodie versus not hoodie is what we are interested in. So we have the number of options and we have this hoodie and not hoodie. Okay, let's get a little bit of information right now. If we look at our first question, it says, what is the 90% confidence interval for the proportion of all students who prefer hoodies? Okay, so we want to make a confidence interval. Over here on our confidence interval page, it's kind of like page 3. The first question that we ask ourselves is, are we dealing with categorical data or numerical data? And we have decided that, hey, we know our variable, we know our data type, we know our categorical data, and so we know that we are going to be dealing with proportions. So we have our proportions here, and here are the key variables that we need to be focusing on. So the first one is our confidence level, and it was given to us right away. So we have our confidence level, and it says that we want to do a 90% confidence interval. So it's going to be 0.9 is our confidence level. As soon as we know our confidence level, look over here, our next item down, we're just going to work our way down this list, is alpha. And alpha is just the percent that we're going to miss the true mean. Confidence level is the percent of the time, if we were to do this over and over again, that we actually hit the true mean. And so our alpha level is just going to be equal to 1 minus our confidence level. Great. Next thing that we're looking for is n, is our sample size. And it gives us to her, we have a total sample size of n equals 76. That's the total number of people sampled. And we have a k. And k is just the number with the trait of interest that we are interested in. So the number of the trait of interest here is going to be equal to 29, because it says that, hey, those are there are 29 people who have this trait of interest that they actually wore this hoodie. Okay, at this point, we can keep on going down. We also know what the sample proportion is then. So we know that the sample proportion, P, is just going to be equal to, as it says over here, K divided by N. And so we're just going to do K divided by N and hit enter. And we have our sample proportion right there. Let me kind of format this a little bit. Okay, after our sample proportion, we want to do our standard error. So we'll go standard error. Now, in our standard error, we typically, or how we've done it previously, is we use square root times pi times 1 minus pi divided by n. The problem is when we're doing a confidence interval, we don't know what pi is. We literally have no idea. Because we don't have any idea, we have to use the next best thing, and our next best thing that we have is our sample proportion. So here we go. We're going to do the square root of our sample proportion times 1 minus that sample proportion, and we are going to divide that by our sample size and close it off. That gives us our standard error. So now we have to decide, are we doing a two-tailed or one-tailed? And because it asks just for, it says, what is the confidence interval estimate for the proportion of all students who prefer, let me just make sure that's where it ends. Yes, who prefer hoodies. And so it didn't give us any directionality. So we are going to do we need a Z2T for Z for our two-tailed. And it gives us how to get this Z critical value. And it gives us this norm.s.inverse calculation. Let's go ahead and do it. And we'll do norm.s.inverse. And let's type this out. 1 minus our alpha value divided by 2. And we can hit enter there. And we've got this z-score, and we can now type out our margin of error, our MOE, margin of error, and that is just equal to that z two-tailed times the standard error, and now I have margin of error. Okay, I'm going to pause here just for a second, and before I do anything else, I want to draw a picture. So I'm going to grab out my handy-dandy pen, and let's just start off with blue. And I'm going to just draw this distribution roughly of what this is. So the reason why I'm doing this is because I want, before I make an answer to this, I want to have a rough idea of where I think that this answer is going to be. So whenever we do the central limit theorem says our sampling distribution in the correct circumstances is going to form a sampling distribution that is approximately normal. And when we are dealing with categorical data, we need at least like 15 successes and 15 failures. So if we look over here, we have at least 15 yeses. We had like 29 yeses, and 29 minus this 76 is going to be way over 15. So we have at least 15 yeses and 15 nos. Now we don't know what pi actually is, right? We don't, this is unknown. This is why we're doing a confidence interval. We want to give us a range of where we think that pi value actually is. So what we're going to do is we're going to center this thing on our sample proportion of 0.38. Now, this is a rough drawing. Whenever we are actually doing our calculations, we are going to do them all the way correctly. This is just giving us an idea. And then I'm going to put in my plus or minus like 1 standard error, and I have the standard error of 0.055. I'm going to do this just for being rough as 0.06. Again, do not type 0.06 in as your standard error when you're calculating it, but this is just to help us get some rough ideas. So this is going to be then 0.44, and if I go 2 standard errors up, that's going to take me to 0.5. If I go a standard error down, that's 0.32, and if I go down another standard error, that's 0.26. I'm just stepping by 0.06 at a time. All right, let me change my color real quick. So this problem asks us to make a confidence level, and it didn't give us a directionality on it, so we're going to have two tails, and it wants us to be the middle 90%. Well, I know that using my empirical rules right here would be the middle 68%, and I know these guys right here are going to be the middle 95%. So immediately, my guess is going to be, if I'm guessing what's going on, let me get another color. Let's just go ahead and grab some black so that I can say what I think that I'm going to be doing. So if I had to make a guess for my 90%, I think I'm going to go kind of right about there. And, oops, sorry, I'm going to go right here. I am confused why that's doing that. Okay, let me just change my color real quick. There we go. We'll make this, sure, we'll make it this purple. I think 90% is just going to be a little bit on the insides of those two. So my guess is going to be something that around 0.25 to 0.49. That's kind of my guess, right in that range. A little, not 0.25, that doesn't make any sense. Not smaller than there, maybe 0.27. That's going to be my guess of where I think that this true, where I think that the true proportion pi is in this region. This is before I did any calculations. All I've done is I've calculated out the standard error. I know what my sample proportion is, and I drew it out. So I'm just going to go look at my answers right now to see if I have anything that's in that ballpark. So when I look at these answers, it says that I could have something in the range of 26 to 49. Like, okay, that one's pretty close. It says 24 to 46. Like, okay, I don't think it's 24 because 24 like chalks me off a little bit too far down. 25 is still too low. That's a problem. 26 and 29, I thought it was closer to 27. So if I had to just do a guess, I would do either A or I would do C, because I'm not quite positive which of those ones are correct. So we've got A and C that are really close, but I was able to get rid of B and D like pretty quickly. So I think it's going to be either A or C. Let's go and show ourselves that this highlighted answer really is this correct one of letter C. All right, so in order to finish off this confidence interval, let's go ahead and minimize that. Let's put this over to the side. And now let's see exactly how we calculate out these two-tailed confidence intervals. All we have to do is do for our lower tail. Let me scoot this over, and I'll just call this lower, or for just L for lower, and U for my upper. All we have to do for the lower is take our sample proportion and subtract off the margin of error. And for my upper, I'm going to take my sample proportion and add my margin of error. And so my guess was 27 to 49, and that wasn't exactly right, but it was in the ballpark. And the correct answer is 29 to 47, which lines up with, I'm going to blow this up all the way. Let's pull up this guy, 29 to 47. So that's how we do a confidence interval. And this is a problem on the spring final of how this was done. This was what, spring of 2024. Let's look at another one. So another problem that we would have in here. So it says, if your supervisor asked you to increase the confidence level of this estimate to 95% and to explain the result, what would you tell them? Now, if you've done this in Excel, this question is super easy to answer. All you have to do is change this from 90 to 95, and guess what? It updates everything. Look at that. Like everything updated, your upper and your lower, all of those calculations already updated for you. If we go from 90, notice how it changed the Z2 tail, the margin of error, the lower and the upper. Those are all have some direct calculation from our confidence level and our alpha level. Let's go back and make this 95. So notice how our answer is 28 to 47 or 29 to 47. Let's look at our lower and upper now. Now it's 27 to 49. So our confidence interval has gotten wider as we made our confidence level wider, which means, yeah, if you want to be more confident about your results, you have to widen out your interval. So let's take a look at what our options for our answers are here. So answer 1, we will be less confident that our interval estimate includes a population proportion, but the interval will be wider. Well, we're not going to be less confident because instead of 90% confident, we're going to be 95% confident. Okay, so here, we will be more confident. Okay, that our interval estimates includes the population proportion and the interval will be smaller. Well, the interval is not smaller, our interval is going to be wider. Let's look at C. We will be more confident that our interval estimate includes the population proportion. That's true. We went from 90% to 95%, but the interval will be wider. That's true. The interval got wider because in order to be more confident about something, we have to include a wider region of our data. And we will not be less confident, but in the interval will be smaller. That one's wrong too. So we've got C here, and how do we check that? We'd be like, well, okay, if I go from 90% confidence to 95% confidence, my confidence level in my interval has gone up, that I am more confident that this interval contains the true population proportion, and the confidence level, or the confidence interval lower got smaller, and the upper got bigger, effectively making our entire confidence interval region wider. All right, let's look at one more. I think this is the last one in this part. Okay, which of the following would be true if you had sampled 56 students instead of 76? Well, guess what? This is also going to be a simple fix too. Like, all we have to do is change here from 76 to 56, and we can see what's going to happen. What's going to happen to our interval? So we started at 76, and here's our lower and our upper. What goes if we go to 56? We go to 56, notice how our lower now is at 40 and our upper is at 60. Yeah, so we've gotten quite a bit wider. Now, the one thing that we do have to see is that, like, if everything else stays the same, what's going to happen to our interval? Now, if you looked at the lower and the upper, the whole thing moved because our sample proportion is like way different now, right? Instead of being, let's go back to 76. Instead of being 38, now we are all the way at, let's go to 56. We're now at like 51%, but let's look at the difference between our upper and our lower. Let's look at like the confidence interval, I don't know what we'll call this, like range. And our confidence interval range, we could just do simply equals to the upper minus the lower, just to see the width of this thing. And so it was a width of, let's start off with 76. The width was like 18 units, or 18 like percentage points. And then if we change this thing to 56, the interval got wider. And the reason is because our margin of error, our standard error, got wider as well. Notice how our standard error is calculated. It's the sample proportion, and then we divide by our sample size. All right, so let's go back to the question here. It says, which of the following would be true if you had sampled 56 students instead of 76? The interval estimate would be larger, all else equal. Constructing a confidence interval would be impossible. No, it's not impossible. You can still do a confidence interval. We would commit a type 1 error. Well, type 1 errors are possible, but it's not necessarily going to happen. And the confidence level of the estimate would be different. The confidence level would stay the same, but the only thing that would be is that your interval estimate would be larger if everything else is equal. And so you can check that. Just do it from your Excel file. Anyhow, so again, like this confidence interval stuff, the big thing here is just being able to calculate out your key variables and then apply them to your interval, whether we are doing a two-tailed interval or a one-tailed, and you plug in the values that you get from your key variables. Hope that helps you out, and good luck.